think it worked. So the factoring we're going to review today is factor by grouping. So not AC grouping. Sorry, Chelsea, not the AC grouping, which I know is your fave.
Oh, it is. How can I factor without Nina? This is so sad.
Yeah, it is kind of sad. Maybe I.
Bring her in.
Where is she? We can FaceTime her.
That is a great question. I have no idea. What
I don't know where she is either right now.
What I'm
so.
positive is it can't be that important.
Oh, she's in Latin.
Oh,
That's not that important.
That doesn't matter.
Who cares about Latin?
That's what I'm saying.
Who's good? Who's gonna
So-
taking whatever they're 40 in Latin?
You are.
No, I speak German.
Latin is a dead language.
yeah, because
Okay,
we
that's
need
actually false. I
the
hate
medical
Latin,
field.
but like,
Latin is
you
fun
use
word.
it every
That's
day.
why. Isn't it like the building block of language?
Yeah.
But like,
No.
No one cares.
I don't know. I'm just trying to say that to sound
to
good.
learn all the other
It's
words.
just
and
a lot of
stuff.
stuff.
Yeah.
Since it's not dead, it's just on life support.
Oh, well, there you go. That's a good way to look at it. So factoring is definitely not dead and used in all of the math classes. If this is factor by grouping, so it's not multiplying A times C, you're just looking and grouping things together. What would you group, or how does it work with factor by grouping, Brandon?
You group the A's together, you group the B's together, you group the C's together, you group the common factor.
Okay, so you group the common things together. So you don't have to keep it the way it's written. You're allowed to rearrange the terms and group together what you want to group together because you think they have something in common. So he said, let's group the A's together. So these two have an A and the B's together. So we have a negative 5B and a negative 10BC. So you're grouping them together because you say, hey, these two terms have something in common. Brandon, what do you do with that thing that they have in common?
You factor it out.
All right, so what do the first two terms have in common?
3A,
3A, and then inside you write.
1 plus 2C,
And then the next two after my bar have what in common?
a negative 5B.
A negative 5B, and then in parentheses.
You have 1 plus 2C.
So with factor by grouping, if these parentheses are not the same, are you allowed to continue on?
No.
No. If they're not the same, you did something wrong. You have to start over and regroup a different pair together. So the parentheses must be the same in order for you to then continue with the grouping process. The goal is to have complete multiplication. So because the pieces in front are like terms, they're being multiplied by the same quantity, you're allowed to pull those together in their own parenthesis and multiply them by that same quantity. It's just they're grouped together now instead of being separate. And that works because they're like terms. They have the same piece behind them, so that's why you're allowed to pull them together. Please make sure that you aren't making this into multiplication. Like a common thing that I see are people trying to just like put parentheses around here and a quantity that was addition and subtraction magically becomes multiplication, but it shouldn't be multiplication. So that's why I just draw a little line to separate them. You don't need to draw a line to separate them, fine. But don't put parentheses around things and make it all of a sudden magically into a multiplication problem. Make sure the previous is equivalent to the next. All right, so number 2. 6x, 3y, negative 12ax, negative 6ay. What could you do first? Sabrina? Yeah, so you can always take a GCF out. That's the question that we should be asking ourselves every single time. Do they have something in common? And she said they have a 3 in common. If you don't take it out first, then make sure you look at your answer and make sure it's completely factored. Do the parentheses have anything in common when you're looking at the answer? So always check for that common factor. All right, Serena, what else could we do? Yeah, so let's just kind of rearrange it, grouping the x's and the y's together. And see what happens. So what could you take out of the first pair, Sabrina? A 2x, and what do you have left? So 1 minus 2a. What would you take out of the second pair? A y. Again, make sure, I know you think this is me being nitpicky, but you need to have a plus sign with the y. Because it's still addition. It hasn't turned into multiplication. And if you don't have a plus sign there, and it's just a y, then it's saying that everything is magically being multiplied together, and it isn't yet. So you're taking out a positive y, and we still have a 1 minus 2a. So that little plus sign is really important. The previous needs to be equivalent to the next. It doesn't change to complete multiplication until you group the pieces together. So 2x and y, the parentheses are the same, so we can pull them together in one parenthesis. 1 minus 2a, that was the quantity that ended up making them like terms. And then the 3, don't forget the GCF. Probably the most common mistake is to forget the number that you pulled out first step. Anybody do it differently? So there's a couple different ways that you can group them that you'll still get the same solution. Now number 3, Nick, what do you notice with number 3?
They all have an X in it.
Yeah, they have an X in it. So pull out an X. Oops, took out too many X's there. And then you probably don't need to rearrange these because they all have X except the plus 1. So if you just look at the first pair, and then we'll group the second pair. Nick, what could we take out of the first pair?
X squared.
Yeah. Technically, Nick, what would the last, like that second pair have in common?
A 1.
Yeah, technically a 1. If you want to write the plus 1, you can, or you could just keep it as x plus 1 separately, but don't change it to all multiplication. So just make sure that you're either leaving the x plus 1 separately, you keep this plus sign in the problem somehow, and then grouping the x squared plus 1 with the x plus 1, and then the GCF of the x that we took out. Can it be factored anymore? Can we factor that x squared plus 1?
Do we want to have imaginary numbers?
We don't want to have imaginary numbers. So if we were working with imaginary numbers, we could factor that further, but it gives us an imaginary number. What does it have to be, Brendan, and if we wanted to factor it? A minus sign. So x squared plus 1 is not factorable. If it was x squared minus 1, then we could factor it one more step. Questions? So the last one of these groupings looks fun because it has 6 terms in it. So see if you can kind of decide how you want to factor it. There's a couple different ways that it'll work. Lots of terms up here. Doesn't look like they have a GCF.
There wasn't just that A at the end, you just take out the next X.
That stinking A at the end. You want a tutor for me after school today, Brandon? I'm a good tutor.
For what class? Being that I missed Thursday and Friday, I'm gonna go over to Zach's house to work on some of the work that I
Okay. Good thing I like the student tutoring. That makes it all better.
Yeah.
Any suggestions about getting these 6 pieces to try and group, Libby?
Can you split it into 3?
Sure. Yeah, so 3 groups of 2?
Yeah,
Okay. The way it is, or did you maneuver them around?
I did it the way it was.
Okay, so you took like these 2, and the last 2?
Yeah.
Okay. Alright, so she's trying to just like 2 pieces at a time still, instead of trying to group 3. So what would you take out of the first 2?
2x squared.
2x squared. And then, in parentheses, you'll have left,
X minus a.
okay, x minus a, alright.
Then it would be plus x.
So positive x, in parentheses you have
X minus a.
x minus a. Looks good so far, they're the same. The last one,
Plus 1.
yeah, plus 1,
X minus a.
x minus a. So that definitely works, grouping them together just as pairs of numbers. All 3 parentheses are the same, so that's good. We can take the 2x in front, 2x squared, the x, and then the plus 1. So as long as the parenthesis is the same each time, you can pull as many terms together. Anybody do it a different way? Sabrina, how'd you do it?
I made 2 groups and 3.
And did you keep them the same or rearrange them?
I rearranged them.
How'd you rearrange yours?
Put 2x cubed plus x squared plus x, and then minus 2ax squared minus ax minus a.
And then what'd you take out of the front?
I took an x out of the front, and it became 2x squared plus x plus 1,
And then out of the second?
a negative a.
Yeah. And you still get 2x squared plus x plus 1. So that works as well. It's just the outside terms are now the x and the minus a. And then the inside term was the 2x squared plus x plus 1. Anybody else do it that way? Good. So either way works. You end up with the same result. Any questions with the grouping? All right. So then soap. Kate, what's soap mean?
Same, opposite, always positive.
Right, so SOAP is the pattern for your symbols in between the letters A and B. So we have the same symbol as what you started with, the opposite symbol, and then always a positive sign at the end. The pattern of the letters for both the addition and the subtraction of the cubes is the same. So you have A, B, A squared, AB, B squared. And then in the middle is SOAP. So AB, A squared, AB, B squared. Probably make a little jingle out of it. AB, A squared, AB, B squared. Someone if you were creative, maybe you'll think of a little jingle. So the first one, x cubed minus 27. So Kate, the cube root of x cubed is?
X.
And the cube root of 27 is? That's how you get your A and B values. So you're taking the cube root of what's there. So then you're plugging in those pieces to the pattern. And again, like both of them are the same pattern. It's just the SOAP part, the symbols in the middle that differ. So it says A, which is X, and B. So there's my A and B. The same sign, well, it's a minus, so it stays as a minus. And then A squared, A times B, B squared. So those would be the numbers going in for A and B. We had the same sign, now we need the opposite sign, and always an addition sign, or always positive. And then it's factored. Can you ever factor, break down that second trinomial, that second piece there? Can that be broken down or factored further? No. And it'll never be broken down or factored any further. This back here is what we call a prime factor. So with the SOAP formula, that second piece, as long as you took out a GCF, will never get broken down or factored any further. Unless, again, you go into the imaginary world. So that is as far as it goes without us using like the quadratic formula. So if you look at number 2, Chelsea, 64y cubed plus 8. Could you take the GCF out first?
No. Would you?
You could,
I mean, yeah.
yeah.
Or you could just keep it as 4.
Or you could just keep it as 4y and do it at the end. So Chelsea, you have it kept, you kept it as, okay. So she kept it as 4y and 2. Okay. So when you factor it, Chelsea, what do you get?
4y plus 2,
That's our a and b with the same sign.
and then 16y squared minus 8y plus 4.
So a squared, ab, b squared, and then SOAP, same, opposite, always positive. So now if you look at this answer, the first set of parentheses have a 4 and a 2. So Chelsea, what can we take out of the first set of the parentheses? A 2. So if you take a 2 out, Chelsea, what does that give you?
2y plus 1.
2y plus 1. The second group of parentheses, I said they were prime unless you didn't take a GCF out. What could you take out of the second set, Chelsea?
A 4.
A 4. And when you take a 4 out, you get
4y squared minus 2y plus 1.
everything is being multiplied together once it's factoring. So if you take a 2 out of the first one and a 4 out of the second, that GCF is 2 times 4, which becomes an 8. You could have taken it out initially, you would get the same answer. So we could take an 8 out right here and get 8y cubed plus 1. And then you'd still factor it and you'd get 2y plus 1, 4y squared minus 2y plus 1. Just kind of depends on what you see first. Questions? For letter C, are those perfect cubes the way they're written? Yeah. So we have 27x cubed. Eris, what's the cube root of 27? And there's an x with it. How about 125? Kate? 5. And that one has a y. So those are perfect cubes. So decide what those values are when you take the cube root and then plug them in your formula. So a plus b, or nope, how about minus b, it's the same sign. So 3x minus 5y. And then a squared, make sure you're squaring the 3 and the x. Opposite sign. A times b, 3x times 5y is 15xy. And then always addition 25y squared. Questions? Virginia, is there anything we have to do with number 4?
We factor out 2x.
Yeah, take out a 2x. And when you take out a 2x, what do you have?
X cubed minus 8.
Right. So you have to take that out in order that they become perfect cubes. And then our a value is x and the b value is 2. And then what do you get, Virginia?
We get, so x minus 2, x squared plus 2x plus 4.
So GCF in front, don't forget the GCF. All right, more problem. This one looks fun. Y to the 9th plus 1. So think to yourself, what times what makes y to the 9th? Sabrina? Y to the 3rd. So y to the 9th is y cubed times y cubed times y cubed. Because remember, you're adding the exponents. So when you add the exponents, that's how you get 9. So our a term is y cubed. So Sabrina, how would you factor that?
You can make it y cubed plus 1.
Okay, so that's a, same sign b.
Y to the 6 minus 5
And then a squared, so 6 cubed, y cubed squared becomes y to the 6th. A times b, well, that's y cubed, and then b squared is just 1. Is that completely factored? Why not, Virginia?
Because you can factor y to the 3rd plus 1.
Yeah, this is still a perfect cube. When your power is big, good chance that you can factor it a second time. So that y cubed plus 1 is a perfect cube, so that would be y plus 1. And then a squared, opposite sign, ab, always positive, addition sign there, plus 1. And then just bring back or pull down the last piece that was in the back. So the last piece isn't changing because that last piece is prime, but the first piece does change. Questions? The larger the power, the more factoring is probably involved. So if you flip the next 2 pages, for some reason I thought it was pages 9 and 10. I did look, double check me to send to you, but it's actually pages 11 and 12 in your packet. It's just the next page. So the front of it, you're doing the odds, and then the back of that is the odds as well. So odds on both of them. The front page would be the grouping problems, the back page would be the scope problems. And then tomorrow, a little quiz. We'll go over a couple more factoring problems. And a little factoring quiz, not until Thursday.